Hello again, ladies and gentlemen. Mr. Donnie here, looking at some chapter 7.6 and 7, metals, nonmetals, metalloids, group trends, problems. All right, so before we get into the problems, let's talk a little bit about the trends. So metals, where are things the most metallic? Well, the furthest to the left and furthest to the bottom. All right, so you can probably see this best at, if you take a look at like group 15. Right, so I'm drawing the stairs for the metalloids and stuff, and if we look right here, nitrogen, nonmetal, phosphorus, nonmetal, astatine, metalloid, antimony, metalloid, bismuth, metal. So we're starting at the top, we got nonmetals, going to the bottom, we got metals. And if we go left or right, lithium, beryllium, metal, boron, metalloid, nonmetal, nonmetal, boom. So things to the left are metals, things to the right are nonmetals. Cool. All right, so taking a look at it, question number 21. Of the elements below, blank is the most metallic. So we're trying to find the one that's most to the left and most towards the bottom. So which one of those is it? It's cesium, all the way down there, right? Can't get any more left, can barely get any more bottom, so it's got to be choice E. 22. Which one of the following is a metalloid? This is just kind of a definition question. You got to know that you got to look at the stairs over here, right, and follow them down, and those things are metalloids. And which one of those options is it? Well, it's germanium, Ge. Right. All right. 23. Of the following elements below, blank is the most metallic. So again, talking about most to the left and closest to the bottom. Well, these are pretty easy, right? Like argon, that's noble gas. That ain't metallic at all. So which one is furthest to the left and closest to the bottom? It's going to be potassium. Potassium, right? Aluminum's right here. It's higher up. Magnesium is higher up. Sodium, higher up. It's going to be potassium. Of the elements below, blank is the least metallic. So if we're talking about least metallic, we're talking about furthest to the right and closest to the top. All right, so which one of those things is furthest to the right and closest to the top? Well, argon's pretty, you can't get any further right, right? We got a metal, we got a metal, we got a metal, we got a metal, we got a noble gas. So that's going to be a right answer right there. 25. This one, you got to kind of just commit to memory from having read it. The acidity of carbonated water is due to the reaction of CO2 with H2O. That's what makes it carbonated. It's also what makes it acidic. So, yeah, there's that. 26. The element in the periodic table that looks like a metal is a poor thermal conductor and acts as an electrical semiconductor. So, looks like a metal. So, we got metallic properties. Poor thermal conductor, that's a non-metallic property. Semiconductor, that's a cross between the two, right? So, we're looking for a metalloid. Something's got properties of both, but is neither. So, which one of these things is a metalloid? Right, electrical semiconductor, you guys should probably think silicon right off the bat because that is used in computer chips, pretty popularly known for that. So that's how you would pick between them. All right, this one's a good one because you guys hate them. You hate these questions. Which of the following are true? Man, it'd be even worse if they said which of the following aren't true. Just totally mess with your head. All right, well, first thing, let's take a look at the configuration they give us. Blank S2, blank P5. So we're talking about having 7 valence electrons, right? So we know we're talking about group 17. We're talking about all these guys. So what do we know is true for all these? Elements in this electron configuration form -1 anions. That is true because it likes to gain 1 to get the 8. The stable octet. This one, number 2, probably, devil's in the details. Elements with this electron configuration are expected to have large positive electron affinities. No, it should be negative. So this one is incorrect. Elements with this configuration are nonmetals. Well, that's true, right? All those things are nonmetals. Elements with this electron configuration form acidic oxides. That is true. That's something you gotta know, right? Like what's one? Anyway, yeah, the Cl2s, right? They pollute the air, the chlorates and whatnot. So which one of these says 1, 3, and 4? Choice B. 28. This element is more reactive than lithium. So we're looking at lithium, more reactive than lithium, and magnesium, but less reactive than potassium. All right, so reactivity, if we're talking about metallic character, it also increases the same way to the left and towards the bottom. So it's got to be more reactive than lithium, so it's got to be lower than lithium, and it's got to be more reactive than magnesium, so it's got to be less than magnesium, but it's got to be above potassium. Which thing are we talking about? Oh, gee, I don't know, Mr. Donahue. Maybe it's the one thing that's being surrounded by all of it. So choice A, sodium. 29. Alkali metals tend to be more reactive than alkaline earth metals. So remember, alkali metals, we're talking about that, and alkaline earth metals, we're talking about group 2. Because, well, let's think about it. Group 1 has only one valence electron. So it'd be pretty easy to just get rid of one valence electron to be really stable, which would make it more reactive, right? So that means it's going to have a lower first ionization energy, which is going to make it more reactive. 30. Element M reacts with oxygen to form an oxide of the formula MO. Mo. When Mo is dissolved in water, the resulting solution is basic. Well, let's break down what we know. If we have M and O, we know oxygen's -2, so that metal has to be +2 for the whole thing to be neutral. All right, so that narrows it down to just one answer. B, Ba, barium. All right, that's what you do with a dead chemist. You bury him. Oh, zing. Well, on that note, I bid you adieu. I see you in class. Hope you found that helpful.